Alright, here we go. So we are going to be solving in radians. The thing I want you to think about is that it's going to feel really, really similar to solving in degrees with a slight change in mindset rather than a whole new process. So things that felt familiar and comfortable from solving in degrees are going to continue to feel comfortable and familiar. So when I'm asking you to find sine of x is equal to 1/2, here's things I want you to know. Sine is talking about vertical position. So that means I want to find on the unit circle where my vertical position would be 1/2. So if I draw out a unit circle, like so, here's 1 all the way up at the top, so here's 1/2 right here in the middle, so I'm going to extend out my line. So that means I am looking for these two values, or these two triangles, where that vertical position is 1/2, and this second triangle right here, where this vertical position is 1/2 as well. So now my next task is to figure out, well, what is this interior angle, this reference angle, so what are my values of x in the end? But instead of thinking about it by going to our special triangles, we're going to think about things in terms of radians. So here's stuff that we get to know. On a unit circle, here's 0. We know a half circle is then talking about pi radians, which means a complete full circle, is talking about 2 pi radians. If you get only a quarter of the circle, then we're talking about pi halves radians. If you get all the way down to here, we're talking about 3 pi halves radians based on how we're cutting up that circle. 1, 2, 3, 4 equal pieces, so we split up 2 pi into 4 equal pieces, which means each little section is pi halves, is how we're getting that. Okay, so pi halves, pi, 3 pi halves, 2 pi, there we go, just like that. So now if I'm trying to figure out on my unit circle, based on where the blue and the purple triangles are, well, what measure of radians is that? It's no longer just talking about pi halves, but I'm going to have to figure out what that is in terms of pi. So I know that if I go from here and I go all the way over, that's talking about pi radians. So but it's going to be split up into some amount of pieces. So this right here we know is pi radians. Here's another thing we know. We know that all the way up here at the top, this is pi half radians. So then now I want to think about, if I'm talking about on this quarter circle right here, on this quarter circle right here, if I went halfway up that arc, well, then that would be half of pi halves, which would then be talking about, well, pi fourths. So right here, this distance would then be talking about pi fourths. However, the angle that we're looking for is smaller than that arc. The angle that we're looking for is on this blue arc right here, in that way, which then is not talking about pi fourths, it's something smaller. If I cut these into as many equal pieces as I could, well, I know I can fit 1. I can probably fit another 2 in there, so that's 1, 2, 3 of them. And then I can probably slice this again. 1, 2, 3, 4, 5, 6. So I have 6 equal pieces in a half circle, where our half circle is represented by pi, which means each of those little angles inside, or that reference angle that I'm now using, is pi over 6. Okay, so that means that in quadrant 1, great, I've straight solved it. I know that x could be talking about pi over 6. However, in our quadrant 2, our other option is that we're talking about this purple angle, which, remember, we measure from our positive horizontal axis all the way over, that direction angle, which means it's like we went from here, we almost did a complete half circle, which would be pi, but we went back by just a little bit. So in order to figure this one out, in Q2 is going to be almost that complete half circle of pi radians minus that reference angle. So then that means we're talking about 5 pi 6. So in this case, our answer is pi over 6 or 5 pi over 6. Similarly, if I wanted to try to solve this next one, where sine of x is equal to root 3 over 2, I'm going to continue with some facts that I know. For a fact, I know that root 3 over 2 is a value bigger than 1/2, simply because root 3 is bigger than 1. They have the same denominator. Root 3 is bigger than 1. That's a fact. The other thing that I know for a fact is that root 3 over 2 is less than 1. And I know that because root 3 is less than root 4, just based on the fact that 3 is smaller than 4, and radicals continue to hold that property of mathematics. So what I mean by that is root 4, oops, come on, let me draw. Root 4 over 2. Well, that's then saying 2 over 2, which is equal to 1. So I know that root 3 is less than root 4, so I know that root 3 over 2 is less than 1. Okay, all of that is a mini aside just to tell us that when I'm drawing out my unit circle this time, and I find that vertical position, it's going to be bigger than 1/2, but less than 1, so it's going to be, I don't know, somewhere right about here, we'll say. So if we put it right about here, then what we'll have is that angle and that angle to find. And this time, well, I've already kind of sliced up my half circle into 3 equal pieces. Here's one piece, here's the second piece, and here's the third piece, which means that there are 1, 2, 3 pieces in pi radians, or each is then pi over 3. So then if I'm looking for this one, I would say, well, in the first quadrant, I'm talking about pi over 3, and in the second quadrant, I am talking about 2 pi over 3. Here is 1 pi thirds, here is 2 pi thirds. This would then be 3 pi thirds that we don't really talk about. My last little hint for you, the options that we really are considering when we're dealing with this at any given point in time: pi over 6, pi over 4, pi over 3, pi over 2, pi, I guess if you want to extend it out that far. Those are going to be our best reference angles and probably our only ones. So keep those in mind, pi/0, I guess, as well. Those are really going to be your only options. You're just trying to figure out how to slice up that unit circle. All right, hope that helps with your solving.